Hello. In the wake of that recent article in the Guardian about evolution, I really would like to talk about the state of evolutionary theory. But first, we need to get clear about what that might mean, because there's a lot of strange stuff out there. What do people mean when they talk about the theory of evolution or evolutionary theory? I don't know. We never hear about the theory of chemistry or the theory of physics. Again, there's a lot of strange stuff. One strange idea is that in science, a theory is a well-established explanation supported by mountains of evidence. And this definition, interestingly, was not made up by random people on the internet. It follows the explicit guidance of the US National Academy of Science in a series of white papers, like this one here. It says the formal scientific definition of a theory is a comprehensive explanation of some aspect of nature that is supported by a vast body of evidence. If that's what theory means in science, then it will only apply we will only apply it to ideas that are well established and not new ideas, and we would never see competing ideas described as competing theories because only one of them could be true. In the original version of this definition, the white paper cited atomic theory and plate tectonics as examples, but both of these were cited as theories long before they were established. So John Dalton was one of the progenitors of the atomic theory, and this is a facsimile of a page from one of his notebooks. And in this notebook, he refers immediately to his atomic hypothesis as a theory. He didn't wait for it to be established. And he and his colleague Thomas Thomson, who published this a few years later in his textbook, they discussed this and other theories as competing theories. And the same is true for plate tectonics. So Alfred Wegner himself called it the Verschiebungstheory, which means displacement theory, and it was not well established for decades due to the lack of evidence and the lack of a mechanism for how continents would move around. So here's a page from a bibliography of sources addressing this topic, and it shows scientists referring to Wegner's idea as a theory and also as a hypothesis in 4 different languages. There's French, there's English, there's German, and Italian. So this is the way the term is used in multiple languages in chemistry and in earth sciences. What about life sciences? Well, Darwin, for example, uses the word theory a whole bunch of times in The Origin of Species, most often for descent with modification and for natural selection, which he often calls my theory. But also here he refers to the theory of creation. Okay, so obviously that's just not what theories mean most of the time. So the neutral theory, for instance, is the substantive falsifiable conjecture that the majority of changes at the molecular level are due to the random fixation of selectively neutral alleles. Okay? The idea of neutral evolution had existed previously in population genetics, but Kimura said, and King and Juke said, this happens way, way more often than anyone had suspected. Now, interestingly, this was not called the neutral theory when it was first proposed. And that's actually not uncommon for something that we later call a theory to be proposed without that label. But it's not really a matter of gaining acceptance. It's more a matter of an idea becoming sufficiently frequently discussed that people want to have a convenient label for it. So the label neutral theory began to appear in the 1970s, but the theory was disputed for decades, and it's still disputed. So in these cases, the term theory means a hypothesis or a conjecture. Each of these theories was disputed on the basis of factual evidence. Okay, so scientists themselves understood these theories to be subject to falsification on the basis of facts. And that, I think, is the most common meaning of the word in science. But, excuse me. But there's actually a second meaning of theory that refers to something not falsifiable, which is the body of the abstractions or formalisms that are relevant to some topic. So I call one of these theory C and the other one theory A. So theory C is the concrete conjectural kind that I just listed. A systematic conjecture like the neutral theory. We say it's good if it matches reality and it can be killed off by facts. But theory A is a body of abstractions relevant to some topic. Okay, it's abstract and analytical. So music theory is a body of abstractions. It's not the hypothesis that music exists. And in music theory, you can make a scale that nobody ever plays, all right? And it's still part of the theory. Same way in population genetics theory, you can have a theory that applies to infinite populations, which don't exist. They're imaginary, all right? So something's valid in theory A if it's correctly derived from its assumptions. A good dictionary, so I didn't make up these definitions. A good dictionary will have multiple definitions of the term theory in it, and they will cover these two meanings. Now, although they'll cover these two meanings, I've expressed this in a particular way that's my own, because that kind of heightens the contrast between them, and I think that you might find helpful to clarify your thinking about theories. And it's also helpful to just look at examples and ask questions like, what kind of a theory is Huxley talking about here when he says the great tragedy of science is the slaying of a beautiful theory by an ugly fact? Or you might think about Marty Kreitman's 1996 piece on the neutral theory, where he's actually arguing that the substantive neutral theory, the neutral theory C that I just explained, was dead, had been rejected, but the theory A apparatus that's used to make predictions was still very valuable, even if the predictions were usually wrong. So that he's actually using the word in two different ways when he says the neutral theory is dead, long live the neutral theory. And scientists, usually you don't see the distinction there. You can't see it just by looking at the word theory, but in my experience, for instance, when you hear the word theoretician, you're not thinking of someone who makes bold conjectures, but someone who works on formalisms. Okay, so this erroneous definition of theory from the National Academy of Sciences would never have happened if they had a non-zero number of philosophers of science on their team, but it did happen. And now this bogus definition has made its way into dozens of resources online. So we usually think of the process of science as something that's self-correcting. It has these feedback loops. This is an error, but it's not really a scientific error. It's an error in a meta-scientific claim, a claim about science and how science works. How do things like this get corrected? I have no idea. I tried a couple of times to get sources, like educational sources, to fix their definition, explaining to them that this definition was wrong. But that got nowhere. Why would they listen to me instead of Neil deGrasse Tyson? I wrote a blog about this with the same arguments, a few years ago, and I don't think that had any effect either. Perhaps if enough people contact the National Academy or some of these scientists, we can get them to correct this error before it spreads any further. But let's return briefly to this issue of what evolutionary theory might mean before we wrap up. So when people are having these discussions about extending or rejecting or maintaining or updating evolutionary theory, do they mean all the theory A, like evolutionary theory A is all of the models or formalisms relevant to evolution, which only grows and never shrinks? And it's relatively easy to diagnose just because if something gets published, then typically it's validly correctly derived. I don't think that's really what people mean. I think they have something more like what's well established, like what are all the correct conjectures, which is something that can grow or shrink. But it's extremely difficult to diagnose. I think everyone just intuitively uses some concept of popularity or human acceptance as a proxy for what's known for what's true. But whereas philosophers actually have periodic surveys of opinion, scientists don't. So we don't really know what the majority of scientists believe about the neutral theory. We could use textbooks, or we could use mainstream thinking, or we could use elite thinking in the Oxford Encyclopedia of Evolution as a guide to what's considered to be established. When I look at it in a subsequent talk, I'm going to think about theories as guides to reasoning. So I will think of them as provisional domain-specific extensions of logic, and the more we trust a theory, the more we will use it just like its logic. But that's enough on this topic for today. So I'll get back to evolutionary biology in a separate screencast. If you're interested in that, just look for my YouTube channel or my Twitter account. And if you want to track down sources, wait until the end of this video, and I'll scroll through some slides at the end that have bibliographic information for all the sources that I've cited. Okay, so today we pointed out a flawed conception of scientific theories that's contradicted by over 200 years of usage. We can verify that it's wrong using readily available sources like Darwin's Origin of Species, but this will probably have no effect. Again, I put these arguments in a blog about 4 years ago and nothing happened. So someone is still wrong on the internet.